Hello everyone, welcome to my YouTube channel. My name is Precious Ugweze, and in this video we're going to talk about functions and mappings, which are just almost the same. Alright, so what is a function? Definition. So we say that a function is with respect to two sets. So there must be the presence of two sets, let's say set A, and then another set B, and two of them must be non-empty, meaning they must contain elements. Okay, so now we say that a function, this is function, a function from the set A to another set B is a rule that shows us how to assign every element of A a unique element of B. So the first thing to note about a function is that every element of A must have a unique element in B. So A can only be mapped to one element in B. If A is mapped to two elements in B, then this is not a function. Okay, so but that doesn't mean that two elements in A cannot be mapped to one. So if I have something of this nature, A now, and then I have another set here, say B here, and then I have, say, the elements here, A, say B, C, and then the elements here are let's say 1, 2, 3, 4, whatever. Okay, and then I have my A mapped to 1 and B is mapped to 1 also, and let's take it that C is mapped to 3. Okay, so this is of course a function, because even though two elements in A are mapped to 1, however, each of them have unique, they have just one single element they are mapped to in B. And so the both of them are, this is an example of a function. And so if we have that function, in some cases we represent it with F, okay, and you can also represent it with any other alphabet, maybe H, G, and so on. Okay, and so in form of explanation, what it means is that a particular quantity is dependent on another. So you say that it is a function of that. So if, for example, Y depends on X, so we say that Y is a function of X. Okay, and we can write this in this form, that Y is a function of X. And then when we want to represent it as a function of moving from a set to another, we can write it this way, that F is a function from A to B. And this can also be written as F is a function from A to B. So these and these are actually the same. So but when we now refer to their elements, we can write here that that 1 is a function of A. That means the value you are getting in B here, which is 1, is dependent on the value of A here. All right, so haven't seen this, we can see some typical examples. For instance, the area of a circle depends on the radius of the circle, and that's why we have the formula A equal to pi r squared. So whatever is the value of our r determines the value of the area of that circle, and the same is applicable to the circumference of a circle. It also depends on the radius of that circle, because pi is actually a constant. And so we can talk about something like the length or perimeter of a square. So you can see that the perimeter of a square is equal to 4L. It depends on the length of the side of that square. So in this case here, we can say that our A is equal to F of R. And here we can say that our P is a function of what? Of L. All right, so this is basically what function is all about. Okay, so now meanwhile, from what we have here, when you have a function in this way, the set where you are starting from and then mapping to another set is called the domain, while this other set B is called the codomain. All right, it's called the domain, and then this one is called the codomain. Now, the elements inside A that are mapped to something in B are called the pre-image. The pre-image. While the elements in B that have something mapped to them from A are called the range of the function. These ones are called the pre-image of the function, while this one, that's pre-image of f, since f is the function. While this one are called the range of the function f. Okay, so if I ask you, and the pre-image, the range you can write as rf or anything. So the range of this function here, f here, is the set 1 and 3. Why the pre-image? We can write it this way. The pre-image is the set A, B, and C. Okay, as we go further, we are going to have some discussions involving these concepts, the concept of domain, codomain, range, pre-image, and all of that. Okay, so other things we need to discuss are the concept here. We said here now that y is a function of x. That means y depends on x. So the variable that depends on another variable is called the dependent variable. So this is the dependent variable, while this one, the x, is called the independent variable. This one determines the value of y. So it is the independent. It doesn't depend on y. Y depends on it. Okay, so the dependent variable is also called the value of the function, while the independent variable is also called, this other one is also called the argument. Now, from the names, you can always see the meaning. Argument means it argues the value of the dependent. It tells you what the value of the dependent variable should be. While value means the value of the function you have defined. For instance, we defined this here. So if I give what the argument is, then the dependent variable now tells me the value of the whole function. For instance, if I say let my r be 7, so definitely you're going to have 22 over 7 times 7 squared, and this is going to give me 154 as the area of that circle, which is now the value of the function in question. From what I just said here now, the codomain here contains the whole of the elements here, that's 1, 2, 3. While the range is just the list of the elements that are mapped to something in A. So in other words, the range of any function will always be a subset of the codomain. And as we go on to make some definitions, you are going to see there is a case where the range will be exactly equal to the codomain. That type of function has a special name, and we are going to look at that. Types of functions. Okay, so there are types of functions to be considered. The first one is called the algebraic functions. Examples of algebraic functions are functions like polynomials, radical functions. We have also discussed radical equations. That's functions with radicals, square roots, or any kind of roots. Now we can also talk of rational functions, etc. Now we have the second type, and they are called the transcendental functions. Okay, so we have example of these functions, the trigonometric functions, the exponential functions, and we have the logarithmic functions, and etc. Okay, so the third one we're going to look at is what we call the even functions. So when is a function said to be even? Okay, so a function f is even if f of minus x is the same thing as f of x. Okay, so examples of functions, for instance, if I have something like f of x to be equal to, let's say, something like x squared. This is a function. So what it means is that if I put a value for x here, I'm going to get something here. For instance, if I say let my x be 2, so my value of my function is going to be what? 4. So in this case here, my x is 2, and then maybe my y, which is f of x, is equal to 4. Okay, so this kind of function is an example of an even function. What does that mean? It means that even if you put a minus as your x, it will still give you the same thing the positive x would have given. We can do an example. Here now we said that f of 2 is 4. So if I decide to look for f of minus 2, I am still going to get 4 because square turns negative to what? Positive. So this is an example. Another example of an even function is our cos x. Cos x is an even function. So what it means is that if I say cos 60, I am going to get 0.5. And if I also say cos minus 60, I will still get what? 0.5. So whether it is positive or negative, cosine returns the same what? Value. So f of negative x will always be equal to positive x. And then another example of an even function is the modulus function, when you have the absolute value of x. So if absolute value acts on maybe 5, I will get 5. And if it acts on negative 5, it will still give you positive 5. And then we have etc. There are many of them. Now, fourth type of function that we should look at here. So here you can see that we have transcendental functions as even, and we also have algebraic functions. Of course, this is an algebraic function, this is an algebraic function, but this is a transcendental function. All right, so the next one we want to look at is the opposite of even functions. These ones are called odd functions. And what are odd functions? Odd functions are functions that when you have f of minus x, it will give you minus f of x. So this one does not change negative to positive value. So examples here, the sine x is an example of an odd function. If you have sine 30, you will get 0.5. Sine of minus 30, if you check it, you get minus 0.5. So it doesn't change negative and all of that. Okay, so other examples here, even tan x is also an odd function. X raised to power 3 and etc. So what is a one-to-one function? If we have a function f from A to B, then that f is called one-to-one. This is another way of writing one-to-one. So it's a one-to-one function if distinct elements of B are assigned distinct elements in A. So for instance, if you have this as your set A and this is set B, and I have A, B, C, 1, 2, 3. So if you have A assigned to 1, B assigned to 2, and C assigned to 3, this is a one-to-one function. Okay, because every element in B has a distinct element assigned to it from A. So if you have now a function where, for instance, I now decide instead of assigning B to 2, I decide to assign it to the same 1. This is still a function, but this is not a one-to-one function because a particular element in B1 here now has 2 elements assigned to them, assigned to it from what? A. So in other words, another way to say this is that 1 here has 2 pre-images, and then these 2 pre-images just have 1 image inside B. Okay, so we now say that this particular function here, assuming this is our f going from A to B, this f here now is not one-to-one. But if you remove this, then the f you have here becomes a one-to-one what? Function. So another way to say this is that if f is one-to-one, f of x being equal to f of t automatically means that x is equal to t. So if I take f of a now and it's giving me 1, and I take f of c and it's also giving 1, it automatically means that a and c must be the same if that particular function is 1 to 1. That means no two elements from A will be mapped to the same. Once you see two elements from A mapped to the same element in B and you are saying that it is 1 to 1, then those two elements must exactly be the same. That's what this is saying. And so if you say this in another way, if x is not equal to t, then f of x can never be equal to f of t in a one-to-one function. So that's what one-to-one is all about. And we can give you examples of one-to-one function. For instance, if I have uh, f of x to be equal to x raised to power 3, there are no two values you will put as your x and you will get exactly the same value. It is not possible. Any value you put as your x will give you a different value once the x are different. So this is an example of a one-to-one function. A typical example we can see, I'm from Nigeria, and so I will give this example. If you have a function h here, taking or assigning a governor of a state to each state in Nigeria, that would be a one-to-one function. So for example, let me give a diagram. So let's assume that this is a set of governors and then in Nigeria, and then you have another set here, set of states in Nigeria. So you see that if you have Governor A and you have state X, Governor B, Governor C, state Y, state Z, every governor is assigned to only one state. You can't have one governor ruling over two states of a particular country. And so this particular map here is a one-to-one function. And then another example could be any function assigning vice chancellors to a university. Every university must have one vice chancellor at a time. All right. So another type of function that we want to look at. All right. So a function f going from A to B is called an onto function if every element in B has a pre-image in A. So what that means is that if I have a set here, A, I, Z here, okay? So, and then a set, the element A here is mapped to X, and B is mapped to Z, and let's say D is mapped to Y. So here you can see, remember I said that elements from A are called pre-images, while the elements in B are called images, okay? Or you can also call them range, okay? So now, since every element in this set here has a pre-image, that means it's mapped to something from A. So you will say that this particular mapping, assuming we call it F, that F is an onto function. Okay, so the implication of this is that remember I said that range is always a subset of the codomain. So whenever the range becomes equal to the codomain, you say that you have an onto mapping. That means every element in the codomain is actually an image. Remember that the range is those ones in the codomain that are mapped to something. So when everything now is now mapped, so you say that the range has automatically become equal to the codomain. And so you call such a function an onto function. And another name for onto function is a surjective function. And that reminds us, another name for one-to-one is injective. You can also call it injective function. Right, so now this is what we call an onto mapping. An example is okay, I've given an example with this diagram here. This example one. The second one is an example that is not onto. Look at it here. If you have F going from R, where R is set of real numbers, to R, so the domain is the same thing as the codomain. And then you define the function f of x to be equal to x squared. This is not onto. Is not onto. Why? Is not onto because not every element in this is mapped. How did you get that? Because if you pick all the elements of the real number, remember that your real number is the numbers on the real line. Okay, so the numbers on the real line, that means both positive and negative. So let me just use the whole numbers. You have 0, 1, 2, 3, and then you have -1, -2. I'm using the integers now. Okay, so if I decide to take the square of all of this, whether positive or negative, remember we said that square is an even function. Okay, so whether positive or negative, your answer, what you'll be getting, are just going to be the positive part of the real line. So that means the range is going to contain only the positive real numbers, which is r plus. And so it doesn't contain all the numbers that are in this set. We also talked about types of numbers, and you will see it there. So that means this is not an onto map, because not all elements of this, has a pre-image in the domain. Okay, so that's an example to be considered. Okay, the other type of functions that we are going to look at, constant function. Okay, so this type of function is a function where every element in the codomain, in the domain, is mapped to a single element in the codomain. This is our domain here, A. This is our codomain here, B. So assume that we have A, B, C, and that we have 1, 2, 3. So if all the elements in the domain are all mapped to a single element in the codomain, you call the function f here a constant function. An example of that is, for instance, f of x equal to 5. This is a constant function because whatever value you put as your x here, you will always get 5. The reason is because by indices, this 5 is the same thing as 5x raised to power 0. So whatever value you put as your x, the power 0 will bring it to 1, and when you multiply by 1, you still get back your 5. So this is an example of a constant function, and you can give yourself many other examples. You remember we talked about constant polynomials when we discussed polynomials, so it's just the same and similar to what we have here. So this is an introduction to the concept of functions, and this is where we are going to end it for this video. Kindly subscribe to our YouTube channel. In our next video, we'll continue with other concepts of functions. Please like, comment, and share our YouTube videos. We'll see you in our next video. Bye.